Today's lesson is on factor by grouping. Now, the reason we want to know how to factor by grouping is because we use this to factor a polynomial with 4 terms. So before we look at anything too advanced, let's look back at something that we've seen before. So 4x plus 4y. If I was to tell you to factor this, you of course would tell me to take out the greatest common factor, which would be 4, giving me left in my parentheses x plus y. Because 4 times x is 4x and 4 times y is 4y. Now what I want you to notice here is that this 4, notice that what came down in the parentheses was the leftover, the x and the y. It was left over because 4 was the same factor. Now I want you to understand this because when you look at something more advanced on number 2, your temptation might be to multiply this back out. But when we factor, factoring is breaking things apart down into its factors. So by multiplying it back, it's going to create a little bit of a problem. But if you notice, this x plus 4 is the same factor. So what that means is that is the greatest common factor because this is a part of the term and this is a part. So what we can do is we can take and bring down x plus 4, that being our greatest common factor, and then notice our leftovers are going to be the 2x minus 3. So in our second parenthesis, we're going to have 2x minus 3. And if I was to write this back, x times 2x, that would be x plus 4 times 2x would be 2x times x plus 4. And if I was to take this entire thing and distribute it back to the negative 3, I would have negative 3 times x plus 4. So looking at number 3, we have these two pieces, 1, 2, okay, and they're broken up by a plus sign here. So our common factors are x minus 8 and x minus 8. So that means we're going to bring down our x minus 8, that is our greatest common factor. And then what's left over? Well, to multiply x minus 8 times what to get x times x minus 8? That would be x. Now what would we have to multiply x minus 8 by to get x minus 8? Well, of course, a 1. Okay, we can't forget about the fact that there's a 1 there. So that we'd have x minus 8, the whole thing, times x, which gives us this first piece. And then x minus 8 times times positive 1 gives me x minus 8. So last one, number 4. So remember, our pieces are broken up by this plus sign right here. So these are two pieces. Their common factors would be y minus 2. So we'd pull out a y minus 2, just like we put out the 4 on number 1. And then we'd write the leftovers. So in this case, our leftover is 3y squared plus 5. And again, if I was to take this entire factor and multiply it by 3y squared, I'd get 3y squared times y minus 2. And if I was to take y minus 2 and multiply it by 5, I'd get y minus 2 times 5. Okay, so I need you to understand this because this is what we're going to be doing today. We're going to be grouping things together and factoring it. So if you look down here, I have all my steps. So the first thing you do when you're trying to factor by grouping is you put the polynomial in standard form. Okay, and this has been something that's been true for all of our factoring problems, so this should be old news. Now, the second step is to split the polynomial into 2 groups. So what this means is we're going to take and we're going to group the first 2 numbers together, so x cubed plus x squared. This is in standard form. And then we're going to take and we're going to group the second 2 pairs of factors together, 2x plus 2. So once we've done that, we then factor the greatest common factor out of each pair. So what we're going to do is we're going to pretend like we're only looking at x cubed plus x squared. So we are only going to pay attention to these first 2 terms. So what is the greatest common factor for x cubed plus x squared? Well, x squared would be the greatest common factor. And we would be left with x plus 1. Okay, so we've just factored this first set of factors, x cubed plus x squared. So then we would put a plus in between, and we're going to do the same thing here. We're going to factor 2x plus 2. So the greatest common factor for 2x plus 2 is a 2. And we're left with inside here x plus 1. So now we factored this second set of factors. So now notice we have a common factor. X plus 1 and x plus 1. So what it means is we write down our x plus 1, just like so, factoring out that greatest common factor, and now all we have to do is write our leftovers. So x squared and plus 2 is what goes into our second parentheses. So we've now factored this into two factor pairs. So that's the steps here on 3 through 5. Now the last step, well almost last step, the sixth step, says to check for differences of perfect squares. So because both of these are sums, these pluses, that means this problem is finished. We don't have a difference of perfect squares. So our answer here would be x plus 1 times x squared plus 2. All right, let's look at some more examples. So now we're going to factor completely. So we have 4 terms. They are in standard form. So we're going to group the first 2. Now this one's a little different because there's a negative here, and that negative has to stay with the 9x. So there's really like a plus in between here because we keep the negative with the 9. So now we're going to look at the first set of factors, this x cubed minus 2x squared. And we're going to factor out the greatest common factor. So in this case, that is x squared. And we're left with x minus 2. Now, negative 9x plus 18, the greatest common factor is negative 9. And we're left with x minus 2. So notice our greatest common factor between the signs is x minus 2. So we're going to write down x minus 2, and then we're going to write down the leftovers. So our leftovers are going to be x squared minus 9. Now, if you remember up here, once you write the leftovers down, we have to check for differences of perfect squares. So right here, on x squared minus 9, that is a difference of perfect squares, which means we can continue factoring it. So x minus 2 stays as x minus 2, and x squared minus 9 becomes x plus 3 times x minus 3. And it doesn't matter the order of the factors. So this is our final answer. There are 3 factors because there's an x cubed. Now there's not always 3 factors, but sometimes there's 3 factors. So number 2 here, we're going to group our first 2 terms. We're going to group our second set of terms and find our GCF of our first set. So y cubed minus 9y squared, our GCF would be y squared. And then what's left is y minus 9. Now, this second part might be a little confusing because y minus 9 doesn't have a greatest common factor. So what we put down here is we put a 1, because basically the greatest common factor from both of these is a 1. And I need a number right there in front of the parentheses. And I'm left with just y minus 9. So now our greatest common factor between the signs is y minus 9. So we're going to write down y minus 9. Our leftovers are going to be y squared plus 1. Now we are going to check for our difference of perfect squares. So this one here is a difference, but y minus 9 isn't perfect squares. Y should be y squared, and since it's not y squared, it's not a difference of perfect squares. Y squared plus 1 isn't a difference, so this is our answer. We're done. Alright, number 3. So this one's a little different, and what makes it different is that when we look here, it has a greatest common factor. Now notice these other ones didn't because they started with x cubed and y cubed. They had nothing else in common. But down here, 8, 16, 2, and 4 all have a GCF of 2. So that means we're left with 4m cubed minus 8m squared minus m plus 2. So this 2 out in front, this greatest common factor, is basically just going to come down into our final answer. So we're really not going to use it, but we are going to look at this 4-term polynomial in the parentheses. So the first thing we have to do is group just like before. So it's a little more difficult when we have all these parentheses. So remember, we're going to group the first two terms, and we're going to group the second two terms with a plus in between. So our GCF for our first two terms is going to be 4m squared times m minus 2. Now, just like before, our first term can't be negative, so we have to factor out the -1 for our GCF. And we're left with m minus 2. So now we have our similar factors, our greatest common factor. So we bring out m minus 2, and we're left with our leftovers, 4m squared minus 1. Now remember, we have to look to see if we have a difference of perfect squares. This first term, m minus 2, is not a difference of perfect squares. However, the second factor, 4m squared minus 1, is a difference of perfect squares, because 4m squared is perfect, 1 is perfect square, and then it's a difference, it's a subtraction. So we're going to bring down our 2, and we're going to write down, m minus 2 next to it, and then we're going to factor 4m squared minus 1. That's going to be 2m and 2m plus and minus 1 and 1. And remember, it doesn't matter the order of your factors. The only one that kind of needs to be in its right place is the 2. It goes out front. And then everything else can be in different orders, but they have to all be there. So there's 4 factors for this problem. All right, last one is number 4. So this one's a little different because it has 2 variables. Now you might be saying, well, wait a minute, Miss Miller, this isn't in standard form. And you're right, it's not, but it is grouped in such a way that it's going to be very easy to factor this. So I've already put this one in the right format for us. And typically, if I'm going to give you one with 2 variables at this point, it's going to be in the correct format to make it easy for you to factor. So we're going to group our first two terms together and our second 2 terms together. So our GCF for our first 2 terms is going to be an A, and we're left with 3a plus b squared. Now our second set of terms, we need to factor out a negative b, because they both have a b and the first term is negative. And we're left with 3a plus b squared. So notice this one is set up so that these leftovers here, these terms when we take out the GCF, are the same. So that means our greatest common factor is 3a plus b squared, and our leftovers are a minus b. So when I look, 3a plus b squared isn't a difference, so that doesn't have a difference of perfect squares, and a minus b doesn't have perfect squares. So this here is going to be our answer.